In this series of videos, I will discuss some of the subjects that students often struggle with in math. In this particular video, I will discuss some operations with fractions. This slide shows the topics that I will discuss in this video, as well as the numbers of the slide so that you can fast forward to the topics that interest you. The slide numbers are located in the lower right-hand corners of the slides. The bottom number of a fraction, which is called the denominator of the fraction, tells us how many pieces each whole should be split up into, and the top number, which is called the numerator of the fraction, tells us the number of pieces that we want to talk about. So, for example, all of the pictures that you see here show 1/2 of a pizza because each picture shows that the pizza has been split up into 2 equal groups, and you want to talk about one of the groups. As another example, both of these pictures show 7/8 of a pie because they both show that the pie has been split up into 8 equal sections and that you want to talk about 7 of the sections. In a mixed number such as 2 3/4, the big number in front of the fraction is called the whole number, and it tells you the number of wholes that you want to talk about. For example, if you wanted to talk about 2 3/4 cups of sugar, this would mean that you wanted 2 full cups and then another 3/4 of a cup. As I told you earlier, all of these pictures show 1/2 of pizza, and this gives rise to the following rule. You can multiply or divide both the numerator and denominator of a fraction by the same number without changing the value of the fraction. You should notice that if you multiply both the numerator and denominator of the fraction 1/2 by 4, you get 4/8. And if you divide both the numerator and denominator of the fraction 4/8 by 4, you get 1/2. You can do this because 4/4 is equal to 1, and you don't change the value of anything if you multiply or divide by 1. You should also notice that if you multiply both the numerator and denominator of the fraction 1/2 by 6, you find that 1/2 is equal to 6/12. And if you divide both the numerator and denominator of the fraction 6/12 by 6, you should find that 6/12 reduces to 1/2. This is another example that illustrates this concept. You can multiply both the top and bottom of the fraction 7/8 by 2 without changing the value of the fraction. And you can divide both the top and bottom of the fraction 14/16 by 2 without changing the value. This is another example that illustrates this concept. Note that all 3 of these fractions show the same portion of the whole shaded, and so they are all equivalent to each other. Also note that you can multiply both the top and bottom of the fraction 2/5 by 3 to get 6/15, and then you can multiply both the top and bottom of this fraction by 2 to get 12/30. Or you can multiply both the top and bottom of the fraction 2/5 by 6 to get 12/30. You should also note that you can divide both the top and bottom of 12/30 by 2 to get 6/15, and then you can divide both the numerator and denominator of 6/15 by 3 to get 2/5. And finally, you can divide both the numerator and denominator of the fraction 12/30 by 6 to get 2/5. Before we talk about this next slide, we need a definition. An improper fraction is a fraction that has a numerator that is larger than its denominator. Since the top number is larger than the bottom number for an improper fraction, this means that improper fractions represent numbers that are larger than one whole. To change a mixed number into an equivalent improper fraction, you can multiply the whole number by the denominator and then add the numerator to the result. This gives you the new numerator, and the denominator should stay the same. So, for example, to change 3 1/6 to an equivalent improper fraction, we should begin by multiplying 3 times 6 and then adding 1. Since this gives us 19, and since the bottom number should stay the same, this tells us that 3 1/6 is equivalent to 19/6. To see why this works, note that there are 3 wholes that each have 6 pieces, and then there is 1 extra piece left over. This tells us that the new top number should be 19. You should also be able to see that each whole has been divided into 6 equal pieces, and so the bottom number should stay equal to 6. To change an improper fraction to an equivalent mixed number, you can start by dividing the top number by the bottom number. The answer is the whole number, and the remainder is the new numerator. The denominator should stay the same. For example, if you want to change 19 over 7 to an equivalent mixed number, you could start by noting that 19 divided by 7 is equal to 2 with a remainder of 5. Thus, 19 over 7 must equal 2 and 5/7. To see why this works, note that we must split the 19 pieces up into equal groups with 7 pieces in each group. When we do this, we find that there are 2 wholes with 5 pieces left over. Also note that the denominator must stay equal to 7 because each whole has been split up into 7 equal pieces. Now let's talk about adding and subtracting fractions. To add or subtract fractions, you must have a common denominator. This means that you must have the same number on the bottom of all the fractions. Then you can add or subtract the numerators and keep the denominator the same. So, for instance, to add 2 ninths plus 5 ninths, we should note that 2 plus 5 is equal to 7, and then we must keep the 9 the same. Note that the pictures here show you that when you put 2 ninths together with 5 ninths, you do get 7 ninths. Like I said in the last slide, you must have a common denominator when you want to add or subtract fractions. Note that the pieces here are not all the same size, and so we cannot take 2/3 away from 5/6 unless we have the same number on the bottom of both the fractions. So, let's get a common denominator. I'm going to write equivalent fractions with a common denominator of 6. In this case, I could write equivalent fractions with denominators of 6, 12, 18, or lots of other numbers. However, if I use any number other than 6, I will have to simplify my answer later. I'll talk more about common denominators later. So, let's multiply both the top and bottom of the first fraction by 1, and let's multiply both the top and bottom of the second fraction by 2. Because the pieces are now the same size, we can subtract the fractions. Note that 5/6 minus 4/6 is equal to 1/6. Now let's talk about adding mixed numbers. I'm going to show you 2 methods that you can use to add mixed numbers. If you find that you have a tendency to get confused when you get a lot of rules, you will probably like the first method. If, however, you don't mind a few rules, you will probably like the second method better. You will find that your numbers will be smaller when you use the second method, and so you will usually be able to get the answer faster if you use the second method. To add 2 or more mixed numbers using the method I'm going to call method number 1, start by changing all the mixed numbers and whole numbers to improper fractions. Get a common denominator if you don't already have one, and then add the fractions. Make sure to simplify your answer. So, for example, to add 1 and 5/6 plus 4 and 7/9, I will start by noting that 1 and 5/6 is equal to 11/6, and 4 and 7/9 is equal to 43 over 9. Next, since the denominators are not the same, we must get a common denominator. To find the least common denominator, you must find the least common multiple of the bottom numbers. The multiples of 6 are 6, 12, 18, 24, 36, and so on. The multiples of 9 are 9, 18, 27, 36, 45, and so on. The smallest number that is in both of these lists is 18, and so that is the number that I want to have on the bottom of both of my fractions. This means that I must multiply the top and bottom of the first fraction by 3, and I must multiply the top and bottom of the second fraction by 2. Now, since I have a common denominator, I can add the fractions. Note that 33 plus 86 is equal to 119, and so I can say that 33 over 18 plus 86 over 18 is equal to 119 over 18. For the final step, I should simplify my answer. If you are working high school or college math problems, you can probably leave your answer as 119 over 18, but if you are working problems at the elementary or middle school level, you probably need to change this to a mixed number. And, of course, to do that, you must start by dividing the top number by the bottom number. Since 119 divided by 18 equals 6 with a remainder of 11, we can say that 119 over 18 is equal to 6 and 11/18. Now let's work the same problem using a different method. To add 2 mixed numbers using the method I'll call method number 2, you can add the whole numbers and the fractions separately. Again, you must make sure to simplify your answer. To work this problem using this method, we must begin by getting a common denominator. The least common multiple of 6 and 9 is still 18. Therefore, I will multiply both the top and bottom of the first fraction by 3, and I will multiply both the top and bottom of the second fraction by 2. Now, note that 1 plus 4 is equal to 5, and that 15 over 18 plus 14 over 18 is equal to 29 over 18. However, this is not simplified because it is both an improper fraction and a mixed number. If you convert the 29 over 18 to a mixed number using the rule that we talked about earlier, you should find that 29 over 18 is equal to 1 and 11/18. So, since we decided that our answer from the last line was 5 and 29 over 18, and since the word and means add, you should be able to see that this is equal to 5 plus 1 and 11/18, or 6 and 11/18. Note that this is exactly the same answer we got earlier, and so both methods give you the same answer. In my next example, I'm going to talk about subtracting mixed numbers. Again, I'm going to show you two methods that you can use to subtract mixed numbers. And again, if you find that you have a tendency to get confused when you get a lot of rules, you will probably like the first method. If, however, you don't mind a few rules, you will probably like the second method better. To subtract two mixed numbers using the method I'll call method number 1, start by changing all the mixed numbers and whole numbers to improper fractions. Get a common denominator if you don't already have one, and then subtract the fractions. Make sure to simplify your answer. For example, to subtract 7 1/4 minus 2 4/5 using this method, we must begin by noting that 7 1/4 is equal to 29 over 4, and that 2 4/5 is equal to 14 over 5. Next, we must get a common denominator. The least common multiple of 4 and 5 is 20. Thus, I will multiply both the top and bottom of the first fraction by 5, and I will multiply both the top and bottom of the second fraction by 4. Now I can subtract the fractions. Note that 145 over 20 minus 56 over 20 is equal to 89 over 20. As I said earlier, this answer is probably fine if you're a student doing high school or college math, but if you're a student doing elementary or middle school math, you'll probably need to simplify this to 4 and 9/20. Now let's work the same problem again using a different method. To subtract the two fractions using a method I'll call method number 2, you must subtract the fractions and the whole numbers separately. To work this problem using this method, we should begin by getting a common denominator. The least common multiple of 4 and 5 is still 20, and so I will multiply both the top and bottom of the first fraction by 5, and the top and bottom of the second fraction by 4. Now, we have a problem. I can find 7 minus 2 easily, but I cannot easily find 5 over 20 minus 16 over 20. Therefore, I will borrow from the 7. You should be able to see that 7 and 5/20 is equal to 6 plus 1 and 5/20. Since 1 and 5/20 is equal to 25 over 20, I can change 7 and 5/20 to 6 and 25/20. Now I can subtract the whole numbers and the fractions separately. Note that 6 minus 2 is equal to 4, and that 25 over 20 minus 16 over 20 is equal to 9 over 20. Again, notice that this answer agrees with the answer that we found earlier, and so both methods give us the same answer. In my next problem, I'm going to work another slightly different subtraction problem. To work this problem using the method I'm calling method number 1, you must start by changing the mixed number and the whole number to improper fractions. Note that 10 is equal to 10 over 1, and that 3 2/7 is equal to 23 over 7. Now we need a common denominator. The least common multiple of 1 and 7 is 7. Therefore, I will multiply both the numerator and denominator of the first fraction by 7, and I will multiply the numerator and denominator of the second fraction by 1. Now we can subtract the fractions. Note that 70 over 7 minus 23 over 7 is equal to 47 over 7, which simplifies to 6 and 5/7. To work this problem using the method I'm calling method number 2, I'll start by noting that 10 is equal to 10 and 0/7. Now I have a problem because I cannot take 2/7 away from 0/7. So I'll borrow from the 10. Since 7 over 7 is equal to 1 whole, you should be able to see that 10 is equal to 9 plus 7 over 7, or 9 and 7/7. And now I can subtract the whole numbers and the fractions separately. Note that 9 minus 3 is equal to 6, and that 7 over 7 minus 2 over 7 is equal to 5 over 7. We have 3 methods that we can use to multiply fractions and mixed numbers. I will discuss the first 2 methods with 3 different examples, and then we'll look at the third method later. Like I said with adding and subtracting fractions, You will probably like the first method I will discuss if you don't like to memorize a lot of rules. To use either of the first two methods that I'm going to talk about, you must begin by changing all the mixed numbers and the whole numbers to improper fractions. Next, if you want to use the method I'm going to call method number 1, multiply straight across and then simplify. For example, to multiply 3/4 by 6/7, you would begin by noting that we do not have any mixed numbers or whole numbers that we need to change to improper fractions. Then you can multiply straight across. 3 times 6 is equal to 18, and 4 times 7 is equal to 28. However, this cannot be your final answer because you must reduce it. We reduce fractions by dividing both the numerator and denominator by the greatest common factor of the two numbers. In this case, the greatest common factor of 18 and 28 is 2, and so we must divide both of them by 2. This tells us that the final answer to this question is 9/14. To see why this rule works, recall that the word of means multiply when it comes after a fraction decimal percent. Thus, this problem is asking us to find 3/4 of 6/7. So, let's start with 6/7. If we want to find 3/4 of this, we want to split this up into 4 equal groups and then find the fraction that represents 3 of these groups. Note that our whole has now been split up into 28 equal pieces, and then we want to talk about 18 of these pieces. Therefore, 3/4 of 6/7 must equal 18/28, or 9/14. Now let's work this problem again using a slightly different method. Again, we must begin by changing all mixed numbers and whole numbers to improper fractions. But we don't have either of those in this problem, so we can skip that part. Before we multiply straight across, we can reduce our answer by dividing a numerator of one fraction and the denominator of a different fraction by the same number. In this case, we can divide both 6 and 4 by 2. 6 divided by 2 is equal to 3, and 4 divided by 2 is equal to 2. Now we can multiply straight across. 3 times 3 is equal to 9, and 2 times 7 is equal to 14. Since 9/14 cannot be simplified any further, this is our final answer to this question. Again, notice that this agrees with the answer that we got earlier. Now let's look at another example. If we want to use the method that I'm calling method number 1 to multiply 5/12 times 3, we must begin by changing the 3 into an improper fraction. Note that 3 is equal to 3/1. Next, we can multiply straight across. Note that 5 times 3 is equal to 15, and that 12 times 1 is equal to 12. Finally, we must simplify our answer. You can do this by reducing the improper fraction by dividing both the top and bottom by 3, and then changing the result, which is 5/4, to a mixed number. Or, if you prefer, you can change the 15/12 to a mixed number first, and then reduce the answer. Either way, you should find that the final answer to this question is 1 1/4. To see why this works, recall that multiplication is repeated addition. So, if you want to multiply 5/12 by 3, you want to add 5/12 to itself 3 times. You should notice that this is what this picture shows, and you should also notice that 5/12 plus 5/12 plus 5/12 is equal to 15/12, which, as we said earlier, simplifies to 1 1/4. Now let's work this problem again, but let's use the method that I'm calling method number 2. To use this method to multiply these fractions, you must still begin by changing the 3 to an improper fraction. Now, notice that you can reduce before we multiply straight across by dividing both the 3 and 12 by 3. 3 divided by 3 is equal to 1, and 12 divided by 3 is equal to 4. And now we can multiply straight across. 5 times 1 is equal to 5, and 4 times 1 is equal to 4. Finally, using the rule that I discussed earlier to change an improper fraction to an equivalent mixed number, this simplifies to 1 1/4, which, of course, is the same answer I got when I worked this problem using the first method. This is another example that illustrates how you can use the first method to multiply fractions. Again, note that we must begin by changing the mixed numbers to improper fractions. This is the same problem as the last one, but now I'll use the second method. Again, I must start by changing the mixed numbers to improper fractions. Notice that I can divide both the 15 and 10 by 5, and I can divide both the 33 and 11 by 11. Next, I can multiply straight across and then change the 9/2 to a mixed number. Again, notice that this is the same answer I got earlier. third method for multiplying fractions and mixed numbers that I'm going to discuss uses a property called the distributive property. It says that if you have a number which I can represent by a, multiplied by the sum of two numbers, which we'll call b and c, you can multiply the a times both the b and c and then put an addition sign between the answers. To use this method to multiply 2/9 by 3 1/5, I'll start by noting that 3 1/5 is equal to 3 plus 1/5. Now, I can multiply the 2/9 by each of the terms in the parentheses. Note that 2/9 times 3 is equal to 6/9, or 2/3, and that 2/9 times 1/5 is equal to 2/45. For my next step, I'll add these fractions together. Of course, you need a common denominator to do that, but you should find that 2/3 plus 2/45 is equal to 32/45. In my next example, I'm going to discuss how I can use this method to multiply 1 4/11 by 3 3/10. I will begin by noting that 1 4/11 is equal to 1 plus 4/11, and that 3 3/10 is equal to 3 plus 3/10. To use this method to multiply these fractions, I must multiply the 1 by each of the terms in the second set of parentheses, and then I must multiply the 4/11 by each of the terms in the second set of parentheses. Now I can simplify all of this. Note that 1 times 3 is equal to 3, 1 times 3/10 is equal to 3/10, 4/11 times 3 is equal to 12/11, and 4/11 times 3/10 is equal to 12/110, or 6/55. When we add all of these fractions together, we find that we get an answer that simplifies to 4 1/2. Note that this agrees with the answer I got in slides 23 and 24. In my next set of examples, I'm going to talk about dividing fractions. To divide a combination of fractions, whole numbers, and mixed numbers, you must begin by changing all the mixed numbers and whole numbers to improper fractions. Then you can copy down the first fraction, change the division sign to multiplication, and flip the second fraction. Then you can use one of the methods for multiplying fractions that I talked about earlier. For example, to divide 2 2/3 by 5, I must start by changing the 2 2/3 and the 5 to improper fractions. Note that 2 2/3 is equal to 8/3, and that 5 is equal to 5/1. Now I can copy down the first fraction, change the division sign to multiplication, and flip the second fraction. Next, I'll multiply the fractions together. This answer cannot be simplified further, and so it is our final answer to this question. To see why this rule works, you can recall that when you want to divide two numbers, you want to split a number up into equal groups. In this case, we can say that we want to split 2 2/3 up into 5 equal groups, and we want to know the number of parts in each group. So, you should notice that this picture shows 2 2/3, and you should also note that these horizontal lines split this 2 2/3 up into 5 equal groups, and that the area shown by the pink stripes represents the portion in one of these groups. Finally, note that each whole has now been split up into 15 equal pieces, and that we want to talk about 8 of these pieces. Therefore, 2 2/3 divided by 5 must equal 8/15. To see why this rule works, you can also recall that division is the opposite of multiplication. For example, if you want to find 36 divided by 4, you want to find out the number that you want to multiply by 4 to get 36. So, if you want to find out what 2 2/3 divided by 5 equals, you want to find out what you need to multiply by 5 to get 2 2/3. Now let's look at another example that illustrates how we divide a combination of fractions, whole numbers, and mixed numbers. To divide 2 1/6 by 2/3, we must, of course, begin by changing the 2 1/6 to an improper fraction. Next, we can copy down the first fraction, change the division sign to multiplication, and flip the second fraction. And now I can use one of the methods that I discussed earlier to multiply the fractions. You should be able to see that 13/6 times 3/2 simplifies to 3 1/4. To see why this works, you can recall that when you want to divide two numbers, you want to split one of the numbers into equal groups. In this case, we can say that we want to start with 2 1/6 and see how many groups of 2/3 we can make. So, you should notice that this picture shows 2 1/6. And now, notice that the dashed purple lines help split each whole into thirds. Next, notice that we have 3 full groups of 2/3 and then a part of another group. Also notice that the last group has been split into 4 equal pieces, and that we want to talk about one of these pieces. To see why this rule works, you can also recall that division is the opposite of multiplication. For this example, you want to find out what you need to multiply by 2/3 to get 2 1/6. This is another example that shows you how you can divide two mixed numbers. Again, notice that we should begin by changing the mixed numbers to equivalent improper fractions. In my last set of examples in this video, I'm going to look at some applications of fractions. In my next example, I'm going to discuss how we can find the number of hours in 3/4 of a day, and I will work this problem using two different methods. For the first method, I will start by drawing a picture that shows 24 hours. Now, I want to split this 24 hours into 4 equal groups and find the number of hours in 3 of these groups. If you count the number of shaded boxes, you should find that there are 18 shaded boxes, and so there must be 18 hours in 3/4 of a day. Now let's work this problem again using a different method. Recall that the word of means multiply when it comes after a fraction decimal percent. This means that we can translate the phrase 3/4 of a day to a mathematical problem like this. Since 3/4 times 24 is equal to 18, this tells us that there must be 18 hours in 3/4 of a day. In my last example in this video, I'm going to look at another word problem. I'm going to suppose that Patricia has a piece of ribbon that is 8 feet long and she wants to use it to make some bows. I'm going to find out how many bows she can make if each bow uses 2 1/4 feet of ribbon. Fractions scare a lot of people. Thus, you might find it helpful to think about how you would solve this problem if the 2 1/4 were a whole number. So, think about how you would solve the problem if each bow used 2 feet of ribbon instead. If each bow used 2 feet of ribbon, you would work this problem by finding 8 divided by 2. So, since each bow actually uses 2 1/4 feet of ribbon, we must work this problem by finding 8 divided by 2 1/4. It turns out that this is equal to 3 5/9, and so we can conclude that Patricia can make 3 complete bows if each bow uses 2 1/4 feet of ribbon. If you have comments or questions about this video, please feel free to use the Contact Us link on our website.